Alrighty folks, we're introducing a new little sub-project today, as if I need another project. I've got so many of them going on that I don't know whether I'm coming or going these days. But that being said, this EV game is something that keeps on giving. So what we're going to talk about today is a little bit about motors and controllers. Now, I've been accused at times of living in the past with DC motors in my projects. I heavily disagree with that. I think that DC motors have been around a long time, and they have a simplicity that I absolutely adore. The simple fact that you can just take a motor, put two cables from it to a battery, and it starts turning. That is kind of hard to beat. But I'm not here to start one of these interminable nonsense arguments that go round in rings about which kind of motor is better for my project. That's an entirely personal choice as far as I'm concerned. But that being said, I haven't actually worked with AC motors in an electric vehicle project. And that, I think, is going to change with the project that we have coming up after the land yacht. Now, what I have on the bench here is something that I've had for some time now, but basically haven't. It's been kind of parked on a shelf there. It hasn't seen the light of day in probably the guts of a year. This is a 48 volt forklift motor. So you might be saying, well, what's so special about that? But what's rather special about it is that it's a 3-phase AC motor. And as far as I'm aware, this came out of a Linde or however that's pronounced fork truck. And believe it or not, these are quite readily available, and it's quite a nice size of a motor. There's some information available on the rating plate. Some of it's peeled off from just been hauled around the place, but of course it's down the back side of it. Let's see what I can make out here. Let's see, I think it's Sweden. It is made by API Elmo. I'm seeing 174 amps, 2,500 RPM, 85 Hertz, IP20, and a few other odds and sods. It's got a few strange little quirks to it. The first is that there's no drive end bell on it. So we need to manufacture an aluminium plate to go on here that'll center the rotor and pick up on that flange there. As well as that, around the back end, it's got a electromagnetic brake that we'll be taking off. So apart from that, we've got our 3-phase AC terminals with a small wire here with 4 connections in it that I can pretty much assume is for an encoder, maybe even an encoder bearing or something like that. So you might be now saying, well, you know, why are we looking at this? Well, we're looking at it because I'm going to be building an AC motor controller. Now we'll get into the details of that soon, but I just wanted to introduce one of the motors, probably the first motor that I'm going to be testing the controller on, because if I blow this thing up, I'm not too concerned. But that being said, I don't think it'll probably blow up this, it'll probably blow itself up first. Now, that being said, what's kind of gotten me interested in having another look at AC drives, AC motors and associated mechanisms for passenger vehicle applications is something that ended up coming my way thanks to Jack and Anna Kloppenberg and the team at EVTV. Once I get my jacket off, we've got ourselves a cardboard box that my cats have been very interested in from a perspective of sharpening their claws. I've had some packing cases in here with Calb CA series cells in them. They haven't been that interested in the packing cases, but the German cardboard has been a real hit. So there we go. We've got ourselves a Siemens 1PV 5135 AC induction motor, formerly of the famous Azure Dynamics liquidation cell. So first thing I want to say is, as I say, big thanks to Jack, Anna and all of the people at EVTV for firstly for actually picking up all of this stuff, and secondly for putting together a distribution chain that sees it on my garage floor, because that's not easy to achieve. So thanks for that, guys. So as well as the motor, I ended up with a Democ 645. And of course I didn't have the Democ out of the cardboard box 5 minutes, but I had all of the screws out and started having a look into it. We'll have a look at that soon, but this is the primary reason that we're having another look at the possibility of building an AC motor controller, because I can see this baby going in our next conversion project, and I would like to be able to have my own controller in it. I may not, I may have to put the Democ and a Jevku in there, and if that's the case, fine. I can still prap around with that forklift motor and my own kind of ham-fisted attempts at building a controller until I either give up or make something work, and hopefully it'll be the latter. So right, that is kind of just framing what we're trying to do here and giving a little bit of an explanation as to why we're having another look at it. Not only that, but there's other very nice AC components becoming available from the likes of just even recently we've seen the UQM systems from Coda starting to show up, and there was already a crashed Nissan Leaf for sale here on one of the online classified sites a few weeks ago, so I have a suspicion that we're going to be seeing some components from OEM cars becoming available, and they'll all be, of course, AC motors of one form or another, be they induction or permanent magnet or whatever. So I'd like to be at least scratching the surface of some kind of a control system for them. And as well as that, there's the educational aspect for myself there. So I'm going to put the cardboard box back over that so that the cats can not claw the motor on me. And we'll have a look at where I am currently with the controller and some of the details on that. Stand by, folks. Okay guys, allow me to welcome you to the interior of a Democ 645 AC motor controller. So, as I say, I kind of had to cover off this thing pretty quickly after I got it and started having a look in here. Now, those of you that have followed my other DC motor controller videos will know that I utilized one of these heat sinks for that project, and I had picked up 2 of them from a surplus eBay seller last year. So interestingly, when I got a look in here, I'm going to try my best to film this in some kind of sensible manner. The first thing that actually stood out to me was this gate driver PCB here, which is connected to the control board by this ribbon cable. It looks like about a, I'd say it's probably about a 35-way ribbon cable. Now, I'll try and see if we can get in here a bit better at this. But this board, now I'm sure that it has its reasons for being this way, but it's very complicated. There's a lot going on that card. Probably things like shoot-through protection and DSAT detection and anti-commutation circuitry and God only knows what else going on there. But it's a fairly complicated card. There's a lot of components on there that, just by the very nature of their appearance to me, I would say would not be standard parts that you could just pick up from most electronics suppliers. And I would also be concerned that fault finding that card in the event that there was a problem would be quite challenging. But that was, as I say, just the first thing that jumped out at me. Now, I have some experience with IGBT drivers, admittedly single channel stuff, so it did strike me as a little bit complex. So then had a look here at the bus capacitors and the power electronics layout. Now, unfortunately, it's not very visible here, but essentially the power stage in this controller is basically laid out. We have underneath here, you probably just see one of them here at the edge of it. We have 3 CM600DY12NF IGBT half bridge modules, and the capacitors for the DC link. These are 1800 microfarad 450 volt electrolytics, total of 6 pieces. And on the ends here, both where the DC comes in and on the far end, there are some MKP snubber caps, and we've also got a bleed down resistor there for discharging the DC link voltage when the controller is turned off. So then we have our DC supply coming in, and then up here on the front we have our current sensor board, which is two current sensors sensing the current on 2 of the motor phases. They look very like the LEM HDFS 800p part that I used on the DC controller. So that's just the first look, and kind of, as I say, the first impression that I had about the power stage of the Democ 645. Now, I'll try and get a look in there. Hopefully be able to show you the kind of control board. It's kind of hidden in there behind all those ribbon cables, but not really going to be able to see too much of it. But it's a card probably about, I'd say, maybe 6 inches by 7 inches, and it's a very complicated card. There's a lot of I think it's almost all surface mount parts on it, and there's a lot of processors and things going on there. So that again, I mean, it's perfectly fine. Please don't misinterpret what I'm saying here. I'm sure it's a very well built controller, but just from my own, I suppose, rather simplistic view of these things, it does look like it would be very difficult to maintain this if there were any problems with it. But that being said, there shouldn't be too many. So anyway, that's the Democ, and so let's say between looking at this controller and looking at the Siemens and my little 48 volt AC motors that I have, that kind of prompted me to have a look around and see what was going on with respect to people that were working on AC controller projects. So on to my own interpretation of some of that stuff. So I think you will all agree this looks a lot more like my ham-fisted interpretation of a AC controller. Now, as I said, when I started getting interested in this stuff again, I started having a look around some of the various forums to see what other people had been up to. And I was quite surprised to find that one such design had been quite well worked out and was actually available as a kit. Now I must apologise, I'm probably going to pronounce this name completely wrong, but it was designed by I believe a German gentleman by the name of Johannes Hübner, and I do hope that I've pronounced that correctly. Because it's been a long time since I sat in a college German class. So this kit comprises a number of PCBs and components. The first PCB you can probably see here is the current sensor card, and this uses two I believe 400 amp Hall effect current sensors mounted on a very simple little through-hole PCB with some discrete components on there. And this card senses the current in two motor phases, and also senses the DC bus voltage, and has a connection for a heatsink temperature sensor. So this is quite a nice little card. It's all through hole. It was very easy to populate this. It was just basic component soldering. The components were supplied individually marked, which was quite impressive, and that's the first kind of block here. Now the second block is this little fellow here, when there's three of these, and what you're looking at here is a dual channel IGBT driver board, and I think you'll agree that that is a lot simpler in design and construction than what's in the Democ. So we'll be fitting three of these 1 per IGBT brick, and they'll be fitting in on the far side pretty much like so. Begin there, and so that lets us do our sensing, and we've our three. Again, these are CM600DY. Whoops, the daisy, I've just broken that. 12NF. Oh, dropped it again. Butterfingers today, but it's not broken. Woohoo! So, where was I? Yes, CM600DY 12NF transistors, half bridge modules. Again, these are ex-Democ, ex-Azure liquidation sale, as is our trusty heatsink. Again, what I did for the cable glands was what I did for the DC controller. I just used some nylon 25mm compression glands and fitted them into the holes here with good fast setting epoxy resin, which has worked perfectly on the DC controller and doesn't have any problems here in this application either. So transistors on our three-phase output wiring. We then have some copper bus bar providing our DC link, and I've basically simplified the Democ design. Instead of the kind of laminated layout with the capacitors lying horizontally, I've just decided to, this is experimental hardware, we want to keep things as simple as possible. So we've got two copper bus bars, four of the 4500 microfarad, or sorry, 1800 microfarad 450 volt capacitors, and we have a snubber at each end. So that's pretty much the DC link. Over here then we have a, let's see if I can get this thing to turn for me. For here, hope you'll be able to see, we've a kilovac, it's a 250, it's an EV250 2A contactor, pre-charged resistor, and that pretty much is where we're at with the hardware. So we have DC in and three-phase AC out. Now the really interesting part about this system is the control board. So I'm going to get to that now. Are you able to see the complexity of the control board that's in the Democ? Well, this one is a hell of a lot simpler, and it's based around an ARM3 processor. Now unfortunately we're not seeing this too well, probably due to that light. Let me just turn that off and see if I can get a better view of this thing. Never seem to have the right light for the right occasion. Let's see here. Okay, now we can see it a bit better. This is the control board that provides the logic functions for the controller. It's a very simple card. It's about 4 by 5 inches, and the main part of it is this Olimex STM33-H103 microprocessor card. That the central chip on it here is a ARM processor, and there's some support circuitry around that for controlling the various parts, things like IOs and so forth. There's a 5 volts DC regulator up front, and there's several IDC connections for gate drivers, our current sensor board, and various IOs. So I've just mounted this here with a piece of polycarbonate, and we'll be getting everything wired up fairly soon, and hopefully giving some of this stuff a test. So that's kind of where we're at with the AC controller project. What I would like to do, just for myself, would be to redesign this card to have some additional functionality on there, and something like a we got here a 23-way amp seal connector there that I'd like to put onto the board, just to handle all of the I/O stuff instead of these ribbon cables. I think that would make a nice improvement. So I'm going to kind of go ahead and get this controller built up, and actually see if it'll spin a motor for me, and we'll be back with that soon. And that's kind of it for just a quick introduction to this project. Should be quite interesting, and I want to say a very big thank you to Johannes for all of the work that he's put into this kit and for making it available. Certainly opening up the AC side of things for myself, and giving a good platform hopefully that I can build upon and feed some of those improvements back into the project. So stay with us, folks, and we'll be back soon for more AC fun. And as usual, thanks for watching.